Hello everyone, so today I'm going to show you how to graph a rational function. So first, what is a rational function? A rational function is any function that is a division and has x at the denominator. So a rational function can be 1 over x, or maybe it can be 2x over x squared, or something very complicated like x squared plus 3x minus 2 over x to the fourth minus x plus 1. So as long as it has x at the denominator, it will be a rational function. So let's say we're given this equation and we need to graph it. What we do first is we find any discontinuities. There are two types of discontinuities, which are holes and asymptote. Now, a hole is a point in the graph where there's no value for x. So say we have a linear graph that looks like this, and that we have a hole, I don't know, here at 2, 2. So the graph will go this way, but when it gets to 2, 2, there will be no value, there will be a blank spot, but then the graph continues. And an asymptote, it's a line that will divide your graph into two parts, and there will be no value for x in the asymptote. So say we have an asymptote in over here. What this asymptote does is it divides our equation. So I don't know, we could have a line here that runs this way, and then another one that runs this way. So these lines would never get to the asymptote. So first we begin it by getting the holes. To see if your graph has any holes in it, you need to simplify anything that you can in your equation. So in this example, we can simplify both the numerator and the denominator. Let's begin by the top. So we have x to the third minus 9x. So this can be simplified into x times x squared minus 9. And here we have a difference of squares, which can be simplified into x times x plus 3 times x minus 3. So let's continue with the denominator. So we have 3x to squared minus 6x minus 9. Here we can simplify, we can divide everything by 3. So we get 3 times x squared minus 2x minus 3. And we can factorize this. So we get 3 times x minus 3 times x plus 1. So in the end, we have this equation. Now we notice that here we can simplify both the x minus 3 with the x minus 3 on top. So we cross them. And we need to equal whatever's in this parentheses, whatever we eliminated, we need to equal that to 0. So we do x minus 3 equals to 0. And we solve for x. So x is equal to 3. Now this 3 is our x coordinate for the whole. And now we need to get the y coordinate. To do so, we grab the value we got for x, so 3, and we plug it in back into the simplified form of the equation. So we have 3 times 3 plus 3 over 3 times 3 plus 1. And we noticed as well that here we can simplify 3, so we end up with 6 over 4. And this will be our y coordinate. So our whole is at 3, 6 over 4. So now we continue by getting the vertical asymptote. To do so, we need to equal the denominator to 0, because we know that if we have any value over 0, we have no solution, we have an impossible solution, so our graph will never go past this point. We had 3x squared minus 6x minus 9. What we can do as well is factorize. From the factorization before, we know that this is 3 times x minus 3 times x plus 1. And as we know as well, we need to set these values, so this one and this one, equal to 0, and we get our solutions. We start with x minus 3, so x minus 3 is equal to 0. So we solve for x and we get that x is equal to 3. And we also get this one, so x plus 1 is equal to 0. So x is equal to minus 1. Now we run into a problem here. We got that there's an asymptote at x equals 3, but we know that there's a hole at 3, 6 over 4. So in reality, this solution is not an asymptote. It's just a hole. So we only get one asymptote, one vertical asymptote at x equals minus 1. So the vertical asymptote is x equals minus 1. Now we continue by getting the horizontal asymptotes. For horizontal asymptotes, we had 3 cases, and we need to look at the degree of our numerator and denominator to get which case will be. And here are the 3 cases. So if the degree above is smaller than the degree below, then we have a horizontal asymptote at y equals 0. The second case, if the degree above is equal to the degree below, then we need to look at the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. And the third case is when the degree above is bigger than the degree below. In this case, we have what we call a slant asymptote. Now, slant asymptotes are diagonal asymptotes. They can look like this, or they can be this way. And for this, it's a more complicated matter. So in our equation, we have that the degree of the numerator is 3, while the degree of the denominator is 2. So we have in this case the third example. So we need to get a slant asymptote, so there's no horizontal asymptote. So we know that we have a slant asymptote, and we need to get it from this equation. So what we need to do is we need to do the long division from this term over this term. So we need to do the long division of this equation. In order to do it simple, we can use the simplification that we got before, and we had canceled this and this, so we can go do the multiplication and we get, and now we can do the long division. To do the long division, we have x squared plus 3 x over 3x plus 3. So we get this equation, and I know that here we have a remainder, but it doesn't really matter. What you care about is this one. So that is the equation that graphs the slant asymptote. So we have a slant asymptote at 1 over 3 x plus 2 over 3. Okay, so we now know where the hole is, where the vertical asymptote is, and that we have no horizontal asymptote. Instead, we have a slant asymptote, and it is given by the following equation. So now we have our Cartesian plane. It's time to begin graphing the equation. First step, we need to graph the asymptotes. So let's begin by the vertical asymptote. We have a vertical asymptote at x equals minus 1. Now the horizontal asymptote. We have 1/3 of x plus 2 over 3. So we know that our graph will go by 2 over 3. So it's around here. And it's given by 1 over 3. So when x equals 3, it's 3 over 3, 1, plus 2 over 3. So y will equal something around here. You don't need to be that precise since we're just sketching the graph. So now we have both points. We can graph this line asymptote. Now we need to plot the hole. We have the hole at 3, 6 over 4. 3, 6 over 4 would be around here. We have a hole. Now we need to plot points and the two sides that divide the vertical asymptote. So we need to plot at least 2 points in this side of the graph, and we have to put at least 2 points in this side of the graph. So let's begin by the right side. Let's say when x equals 0. When x equals 0, y equals 0. Now we know that 0, 0 is a point in our graph. So now we continue by getting another point on the right side of the graph. Let's use the value x equals 2. So when x equals 2, we get a point that is around here. Now we need to get 2 points on the left side of the graph. Now let's begin with x equals minus 2. So when x equals minus 2, we have minus 2, comma, 1 over 3. Around here. So now we need to graph another point on the left side of the graph, so let's use minus 4. So we get a point that is around here. So now we get these points, but how does the graph actually look? There's a rule for rational functions, and it is that most of them, if not all of them, will look like this and like this, or it could look like this and like this. The point is this shape. We always get kind of an L shape. So by having these points, we know that there's a graph on this side and on this side. We need to sketch a graph that looks kind of like this. We have a hole right here. Now for the domain and range, well, it's pretty obvious. If you have an asymptote at x minus 1, it means your domain will be cut. The domain is not 1, nor is it 3, because we also have a hole in 3, so it will never touch 3 as well. And that's it. That's the only restrictions for the domain. So for the range, it kind of applies the same. It's really obvious. We can see that the range extends from here up to infinity and from here down to infinity. So our range is equal to all real numbers. So now we need the y-intercept. And that's really easy. You just set the value of x equal to 0, so we have again 0 over minus 9, which is 0. So our y-intercept is at 0, 0. And now for the x-intercept, however, you need to make your equation equal to 0. And then you need to solve it. Since the procedure is really long, we will need a whole other video. Just trust me. The x-intercepts are again at 0, 0, and at minus 3, 0. This is everything you need to know on how to graph a rational function. I know it may seem complicated, but you'll get it with practice. I hope this video was helpful to you.